2012 paper 2 problem number 2, we're given a table in which we're going to be expected to, a contingency table, will be expected to perform a chi-square test of independence. So we're told that data has been gathered from a sample of 120 students and that the chi-square test was carried out at the 5% significance level. In all of your problems that you're given on an IB exam, that significance level will be stated for you. You won't be asked to choose that. We're told to write down the null hypothesis. Remember that the null hypothesis says that the two variables are independent. So I've written gender and choice of after-school sport, SPART, are independent. In the next part of the problem, in part B, it says find the expected value of female footballers. So remember that to calculate an expected value, we do row total times column total divided by total total. So female footballers, so our row total for footballers is 85 divided by column total, which is 48. Whoops, multiplication. Went the wrong way there. Row total times column total, and we're going to divide that all by the total total, which is 120, and that's going to give us 34. All right, in part C, let's see, write down the number of degrees of freedom. So remember, degrees of freedom, it just says write down, so you do not actually have to show any work for this problem. That's the number of rows minus 1. So remember, the total doesn't count as a row. Those two total columns don't count as a row. So we have 3 columns and 2 rows. So you've got 2 minus 1 times 3 columns minus 1. So that's 1 times 2 is equal to 2. So the number of degrees of freedom in this problem is 2. In part D, it says write down the critical value of chi-squared at the 5% significance level. Now, before I passed out this paper 2 to you guys, I should have given that to you for 2 degrees of freedom and 5% test. Our critical value is going to be 5.99. You will not be asked to look for that or to give that in the paper starting after 2000 or in 2014. You're going to just be given that in any problem. You will be given that in any problem. All right, now, I do not know how to make this paper longer, so I'm going to have to go on to the next page, I think. Now, in part E, use your graphing display calculator to determine the chi-squared calculated value. I do not have the graphing calculator software loaded on my computer at home, so I'm just going to kind of verbally walk you through how you do that. Remember that what you want to do on your calculator is go to matrices and you set up the contingency that's given to you. So we've got this row by column, so 2 rows, 3 columns. Those values go into matrix A. After you put the information into matrix A, then you do stat, and then you'll see tests. So you want to hit the button on your calculator for test, and you're looking for the chi-squared test. And when you hit enter on the chi-squared test, it asks, depending on the version of calculator, that you have something like, do you want me to put the expected values into matrix B for you? And you just hit enter, and it will do that for you. And then you hit enter again to have the chi-squared value calculated for you. So in part E, the chi-squared value is 2.42. Now, again, you will not be asked on the IB test to calculate that. value by hand. And we've rounded that to 3 significant figures. Oops, put a comma there instead of a period. All right, 2.42. Now, the actual value is 2.42094, but you just want to go ahead and when you're giving an answer, round that to 3 significant figures. In part F, we're going to decide whether or not the null hypothesis should be accepted. So there's a couple of things that you're going to want to talk about. First of all, since the value that you calculated, 2.42 is less than the critical value, which is 5.99, you want to accept the null hypothesis. If the chi-squared value that you calculated is less than that critical value that will be given to you in the problem, then that's when we accept or fail to reject, which is the term I prefer, fail to reject the null hypothesis. So those two variables are independent. Now, you can also, when you did your chi-square test, you got a p-value in your calculator. If the p-value, so the p-value was 0.298, if the p-value is greater than the testing level, so we tested at 0.05, but 0.29 is greater than 0.05, we also fail to reject. That's further confirmation would be another way you could say that. So either one of those statements would be justification for your conclusion. All right, now let's see. One student is chosen at random from 120 students. So what's going to happen here? Let me see if I can cut and paste this table onto the next page. I can probably do that. Copy that and paste it. So often in paper 2, one problem will have a bunch of different parts and they'll be testing you on some different topics. So we just went through a chi-square test and now we're going to switch to probability. Find the probability that a student selected is male. So we're going to use our what we know about probability and we're going to say, well, male students, how many are there? There's 35. So 35 out of a total of 120. And you can leave the answer just like that. That's absolutely fine. This is part G. And then the second part of that question is, so that's G little I. And then the second part of that question, G little 2I, is what's the probability that they play tennis. So again, we're just going to look at the tennis players, and that value is 25 out of 120. You can change your answer into decimal, but you don't need to. You can give your answer as a fraction, and for these probability questions, you certainly do not need to reduce. You're always welcome to, but you don't have to reduce the fraction. Okay, in part H, find the probability that if you choose 2 students, they both play football. So this would be, we pick a student and they play football, so we've got 48 out of 120, and then we're going to pick another student and we're going to multiply those two probabilities together. And so choosing a second student, now I've got only 47 football players and I'm only choosing out of 119. So we're going to multiply those two values together. Oops. And stick a little multiplication symbol in there. Put some parentheses. And the final answer for that would be 94 out of 595. Okay, that was for part H. Now, we want to find the probability that neither of them play basketball. So there are a couple ways that we could do this. You could find the probability that well, no, let's see. If we did both play basketball and subtracted by 1, that would be at least one plays basketball. So let's see. What's the probability that they neither play basketball? Let's take 48 plus 25. What does that give me? 48 plus 25 is 73. 73 out of 120. And then let's multiply that. Again, we're going to have a conditional probability, so we're going to multiply that by 72 out of 119. And that final answer is going to give me 219 out of 595.